You find that a runner finishes her 100-meter sprint in 11.2 seconds. You measure this value yourself. Now you're curious about what her speed is. We calculate speed as distance divided by time. Actually, that's called average speed, but don't worry too much about it. In fact, don't worry too much about the formula at all. What's important for us is knowing this formula, what is the value of that speed? Well, you can just plug into the equation now. You get 100 meters divided by 11.2 seconds. You can plug this in your calculator. And if you do that, your calculator spit out this number. So would it be right to say that this is the speed? No, it's not. Even though this is mathematically correct when you divide these two numbers, when it comes to measurements, we have to precision correct them. And this is not precision corrected. So the goal of this video is to learn how to do precision correction when we're dealing with division or multiplication of measurements. So let's begin. Let's start with a quick recap. When we're doing addition and subtraction of measurements, how do we do precision correction? Well, the rule is that the answer can only have as many digits to the right of the decimal as the value with the fewest digits to the right of the decimal. And we've talked a lot about that in our previous video. So, if you want a refresher on that, feel free to go back and check that out. But now we are considering now the question is, what happens when multiplying and dividing measurements? What do we do here? Well, here the rule is the answer can only have as many significant figures as the value with the fewest significant figures. You can clearly see the contrast over here. We don't care about significant figures. We care about the number of digits, to the right of the decimal. Over here, we don't care about that. We care about the significant figures. Okay. Again, we'll take some examples and it'll make a lot more sense as to what this means. All right, so let's start with our first example. Imagine we want to find the volume of this cuboid, okay? How do you find volume of this? Well, you just multiply the length into breadth into height. So you'll do that. And then the first step is always to just plug it into our calculator. And when we do that, you get 3.2708 centimeters cube, because there are 3 centimeters being multiplied. Centimeters gives you centimeter cubes. Okay. Mathematically, this is fine, but because we are dealing with measurements, we now have to precision correct them. So for that, we're going to look at the significant figures this time. So let's start over here. How many significant figures does it have? Well, all non-zero digits are significant. So there are 2 significant figures. There are 3 significant figures over here. Well, we know here what this and this is significant, and zeros in between 2 non-zero digits are also significant, which means there are again 3 significant figures. Now, which is the value with the fewest significant figures? It's this one. There are only 2 significant figures. Therefore, our final answer should also have 2 significant figures. In other words, we have to round this off to 2 significant figures. Again, it's not 2 decimals, 2 decimals to the right. That's what we did in addition and subtraction. Here, it's the significant figures. Okay, so how do we do that? Well, again, let's look at it a little bit more carefully. For 2 significant figures, I just need this and this digit, which means I'm going to use this digit to round this off. So I don't care about these numbers. So I'm just going to get rid of them. All right, so what's our rounding rule? It's the same thing. If it's 4 and below, we round down. If it's 5 and above, we round up. 7 is 5 and above. So we round this up. So from 2, it goes to 3. And so our final answer is 3.3 centimeters cubed. That's how we, report the answer, which is corrected for precision. Okay. Now, going back to our original question, great idea to pause the video and try and precision correct this yourself. Okay, let's do this. Again, for multiplication and division, this is the rule that we apply. So let's look at the number of significant figures over here. Well, we have 3 significant figures. Over here, well, we know this is significant. What about these trailing zeros? Well, remember, if there is a decimal point, all trailing zeros are significant. All zeros at the end of the measurement are significant. So all of these become significant, giving us 4 significant figures. Which of them is the fewest? Well, this one. The value with the fewest significant figures is this one. There are only 3, which means our answer should also have just 3 significant figures, which means you have to round this off to 3 significant figures. And those would be these digits. So I have to round this off by looking at this digit. So I don't care about the digits that come after that. I can just ignore it. Again, the same rule. Since it's more than 5, I'm going to round this up. So from 2, it goes to 3. So you get 8.93 meters per second. This is the way to measure, this is the way to report this measurement. We have to, the average speed over here is 8.93 meters per second. All right, so let's take a few more examples. Here's another one. Great idea to pause and try yourself first. All right, let's do this. So plug this in your calculator. What do we get? We get this big number. Now, for precision correction, we have to find which one has the least significant figures. So let's start with this one. All non-zeros are significant, so there are 4 significant figures. Over here, I know these 2 are significant. This is a 0 that comes after the measurement, but there's a decimal point, so then all trailing zeros are significant. So 3 significant figures, and then again we get 4 significant figures over here, which means the one with the least is this one. So our final answer should also have only 3 significant figures. If you haven't tried it earlier, good idea to pause now and try. So you have to round this off to 3 significant figures. This is interesting. So this means I just care about these 3 digits, and I'm just going to ignore. So I look at this one to round this off, so I can ignore all of the others. I haven't completely gotten rid of it. You can still see there's a reason for it, and you'll see in a second. But anyways, now we look at this, and look, this is 4, and therefore we round down, meaning this digit stays put. So it becomes what? 683. So is the answer 683 centimeter cube? Well, no, that's not correct, because remember the original measurement was 68,343 something centimeter cube. 68,300 something, right? That doesn't round, you don't round that to 683 centimeter cube. No. That's why I've kept this over here. So what we do is we have to make sure the measurement stays the same, which means you have to add 2 zeros over here. So it rounds to 68,300. Does that make sense? That's the value. And of course, we need to get rid of that decimal point because we want to make sure there are only 3 significant figures, and trailing zeros will be significant if you put a decimal point. But if you get rid of a decimal point, the trailing zeros are no longer significant. So we have 3 significant figures. These 2 are not significant. Boom. There we have it. So which means when we are rounding things, and if you're on the left side of the decimal, please be careful about using zeros. Okay. So the answer over here is 68,300 centimeter cube. That's the precision corrected answer. All right, some more practice problems. Great idea to pause and try them all. All right, let's start with this one. So if you plug this into your calculator, this is the number that we get. That's always the first step. Next, we're gonna look at the significant figures. Well, this has 2 significant figures. This has 1, 2, 3, 4, all 4 non-zero digits. They're all significant. So this is the one that is the least significant figures. So we have to round this off to 2 significant figures as well, which means this digit and this digit. And so I round this off by looking at this one. So I'm not gonna care about all of those others. And again, the same rule for rounding. Since this is 1, I'm gonna round down. So that means it stays put, the digit stays put. So it's 2.7. And there we have it. That's the answer. Okay, try the next one. 17,000 liters divided by 32.6 minutes. And this is the number we get if you plug into a calculator. Of course, the unit also becomes liters per minute. Okay, don't worry too much about the units for this video. It's all about precision correction. All right, so again, how many significant figures does this have? There are 3. How many does this have? Well, we know these 2 are significant, but the trailing zeros are not significant because there is no decimal point over here. So there are only 2 significant figures, which means we need to, this is our measurement with the fewest number of significant figures. So we need to round this off to 2 significant figures as well. So I'm looking at these 2 digits, and I'm going to use this digit to round this off so I can get rid of all of them. But I'll be careful because now we're on the left side of the decimal. So I'll be a little bit careful. So I'm going to keep this over there just for reference. And yeah, so again, same rounding thing. I think we're tired of this now, but I'm just going to keep it over there. So we round this down because this is 1. So you get 52. So is the answer is 52? No, it's not, because the original measurement was 521 point something. It doesn't round down to 52. You have to put a 0 over here and of course get rid of the decimals. So the answer is 520 liters per minute. Okay, on to the last one. Plug this in our calculator to get this number. Count the number of significant figures for each one. Well, there are 3 significant figures over here. And what about the leading 0? Leading 0 never counts as a significant figure. So there are 3. What about this one? We have 1 here, and then we have these 2 trailing zeros, but there's a decimal point. So all zeros at the end of the measurement are significant when there's a 0. So and then there's a decimal point. So we have 3 significant figures. And again, we have 3 significant figures. Oh, so all of them have 3 significant figures. So our answer is also, I mean, you can pick anyone. Our answer is also supposed to have 3 significant figures. So we need to round this down to 3 significant figures. So which means these 3 digits, and I'm going to look at this digit to round this one off. And so I'm going to get rid of the remaining ones. I don't care about them. And again, the same rule. This is more than 5, which means this rounds up. So you get 126 meters cubed. So there you have it. So long story short, when we are adding and subtracting measurements, the rule for precision correction is you have to look at the number of digits to the right of the decimal place, the fewest ones. The answer should have the same as the one that has the fewest digits, okay? When it comes to multiplying and dividing, this time you look at the value with the fewest significant figures, not decimals, and make sure your answer doesn't have any more than that as well.